Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to talk about another way that we can measure the center of a spatial data set by talking about this idea of median center, right? Of median center. So just to recap where we left off, right? We talked about this idea of mean center as simply being the average coordinate of the x and the average coordinate in the y. And by plotting the new point at that average coordinate, we got an estimate of the center of the data set, right? But as we remember when we discussed the review, right, there's another way that we can estimate this center, and that is through this idea of the median. Now, unfortunately, median center for spatial data sets actually does not work exactly the same way as it does in the statistics case. It actually uses an iterative approach. But what I want to do is I want to talk about a concept, hopefully that is a review, called Euclidean distance, and then talk about how this median center actually works without being able to actually calculate it, because it's an iterative algorithm. But let's go ahead and give ourselves a little bit of space here to talk about how median center works. So the definition of median center is that median center finds a location, right? And the key thing here is that this location does not have to be in the data set. I'm going to actually write that in red here, right? Does not have to be in the data set, right? It does not have to be in the data set, right? But median center finds a location that minimizes the Euclidean distance, or distance, because you can define different ones, but typically it's going to be Euclidean, right? That minimizes the distance to all points in the data set. Right? And so typically what will happen, the way that the median center works in order to find a location that minimizes the Euclidean distance to all points in the data set, is what it will do is it will start with an initial guess. Typically this starts off with the mean, and then what it will do is it will calculate the distance between the point that it guessed and all points in the data set. It will then sum that distance to get the total distance between it and all other points in the data set. And then it will shift itself slightly and calculate that distance again. And it will repeat this process until it hits a point where it feels confident that there is no better solution, right? That it can't move itself and decrease that distance. So to sort of put that in more, put that in writing here, right? What the median center tries to do is it starts with an estimate. Right, it starts with an estimated center. This is usually the mean, right? Then it calculates the distance. To all points in the data set. Right, and it sums that distance up. So it gets the total distance from it to all points in the data set. Right, then the algorithm that the internal algorithm then determines a direction to move. So it moves the center. And then it repeats the process, right? It calculates it again. Right, it calculates that distance again to all points in the center, to all points, and sums it. Right, and then it repeats this process until it finds the point with the minimum distance. Until a minimum is found. Right. So again, just to recap, it starts with some estimated guess, usually the mean. Then it calculates the distance from that point to all other points in the data set, sums it up. Then it figures out if and how it should move, and it moves the center, calculates it again, and then it repeats this process of calculating and moving, calculating and moving, calculating and moving, until it hits a point where it feels confident that there's no better solution, and that the point that it returns is going to have the shortest distance from itself, right? So from the median center to all other points in the data set. Okay. So again, the median center, the idea here is that we're trying to find a location such that the distance to all other points is minimized. It's the best possible solution for minimizing the distance from itself to all other points. And it does not have to be a point in the data set. Okay. Since there's no good way to show this equation because it's an algorithm, what I want to do is I want to take the rest of this video to recap this idea of what Euclidean distance is, just in case people have forgotten. Okay. So let's go ahead and talk for a second about Euclidean distance. Right. So Euclidean distance is a measure of distance between 2 points. So it's a distance between 2 points. So you'll typically see those points x1, y1, and x2, y2, right? So this is the x coordinate of the first point, the y coordinate of the first point, the x coordinate of the second point, and the y coordinate of the second point. And we can use just this information, we can calculate the distance between these 2 points. So what we're going to do is we're going to start off by taking the difference between the x's. So that's x2 minus x1, right? So that's the difference between the x coordinate of point 2 and the x coordinate of point 1, and squaring it. And then we're going to add to that the difference between the y coordinates. So it's going to be y2 minus y1 quantity squared. And then we're going to take the square root of that. And this is going to be Euclidean distance. So this equation here, right, this Euclidean distance is going to be what they're trying to minimize. So we're going to try to find a location that minimizes this equation for all points in the data set. That's the goal of the median center. And again, because it's an algorithm, I can't really show you the equation for it. But what I can say is if you plug in the sample points that we have here into the software that actually does the calculations, what you get out is a median of 5.81x and the y of 6.9. 5.73. So if we go ahead and put that in our graph here, right, this is 5.81 is going to be approximately here. And then 6 is here. 6.73 is approximately here. Right, so this is going to be the median. So let's go ahead and label that. This is the median. And then this is the mean. Right, and again, just to recap, what makes the median different from the mean is just the average, whereas the median is actually trying to minimize that Euclidean distance from itself to every other point in the data set. So what this means sort of by default is that the median center is usually the most accessible new location. Right, so the median center is the most accessible. Right, because we tried to minimize that distance, right? That means that for any given point in the data set, relative to the data set, right, this median is the best possible location for accessibility relative to all the points in the data set. Maybe not necessarily just one point, but relative to all of them, this median is going to be the most accessible. Okay, so hopefully that makes sense. Hopefully this idea of starting with an estimate, calculating this Euclidean distance, moving the center, calculating the Euclidean distance again to try to minimize that location. Hopefully that makes sense. And if you have any questions, as always, please reach out. Thank you.